Hello, this is Mr. Stein, and in this video we are going to take a look at parallel, perpendicular, and intersecting lines, edges, and faces. Alright, so let's take a look at intersecting. Intersecting means to meet. You can think of an intersection in roads. It's where two roads meet. So lines. Lines are two-dimensional. Two lines intersect when they cross. So here we have line 1 and line 2. They intersect at a point. Those two lines intersect. We can have lines that intersect like this. These lines intersect at a point. So in two dimensions, lines intersect at points. Now let's look at our edges. Edges are on three-dimensional objects. There's an edge right there. Edges intersect at a vertex. There's a vertex. And you can see that this edge intersects with two other edges at that vertex. There are three edges that intersect at a vertex. If I look at another one, right here's a vertex right here. It has 1, 2, 3 edges intersecting it. In three-dimensional objects, a lot of vertices have 3 edges intersecting them. Some have more. Now faces. Faces are these flat sides of the object, and they intersect with other faces on an edge. So you can see on this edge right here, this face right here intersects with this front face. So those two faces intersect on an edge. If we look at this, right here we have a cube. This face right here intersects with this face along this edge. This face intersects with this face along this edge. This edge, and this edge intersect at this vertex right here. All right, let's take a look at perpendicular. Perpendicular means they intersect at a right angle. We make this symbol for perpendicular. That's the symbol for perpendicular. So we have a horizontal line right here meeting up with a vertical line, and it is perpendicular right there. And they intersect at a point. Okay, now let's look at edges. And let's look for two edges that intersect at a right angle. I'm going to highlight my first two in green. So let's look at this edge right here. That intersects with this edge right here at a 90-degree angle. Now let's look at this horizontal edge right here. It also intersects with this edge at a 90-degree angle. We'd have to turn it to see the 90-degree angle. In this one, it intersects here. This would be a 90-degree angle as well between this top edge and that top edge. Well, let's see if there's some edges that do not intersect at 90 degrees. Well, let's look here. Take a look at this edge right here, this edge right here, and this edge right here. These do not intersect at 90 degrees. You can see that this angle right here is not a right angle. So those do not intersect at 90 degrees. Look over here. This angle, this edge, and this edge do not intersect at 90 degrees. Okay, now we're looking for faces that intersect at 90 degrees. So faces that are perpendicular. Well, let's look at this front face right here. On this triangular prism. And this bottom face. Those two would intersect at 90 degrees. Let's look at our cube. This face right here on top intersects with this face at a perpendicular angle. There's a 90-degree angle between those two faces there. In a cube, any two faces that intersect at 90 degrees. That's not true in a triangular prism. Let's look up here. We've got this pyramid here. Let's look at this side face again. Is it perpendicular to the bottom face? I hope you answered no, because the side face is tilted in a little bit. It's not straight up and down, it's tilted. So it's not perpendicular. That side face is not perpendicular to the bottom face. So you need to know when two lines are perpendicular, 2 dimensions. When two edges are perpendicular, they meet at 90 degrees. And when two faces are perpendicular. Now lastly, let's look at parallel. Parallel lines, they will never intersect. Even if you extend them on forever, parallel lines will never intersect. Those two lines are parallel vertical lines. Edges. We can find parallel edges as well. So let's take a look at this edge right here. Is there an edge that's parallel to it? This one would be. If you kept these two lines, these two edges going off in forever in both directions, they'd never meet. Let's look at another pair. This edge down here is parallel to this back edge right here. Those two lines would never meet. Now, what about parallel faces? Parallel faces, well, we can have two faces that if we extend them on forever, they will never meet. Let's look. In this triangle, you can see this one side face here meets this back face here. The only two parallel faces we have on here is this front face is parallel to this back face here. Those are the only ones that are parallel. If we look on this cube, the top face right here is parallel to the bottom face. Right, if we look at this cube, this face would be parallel to this face on the other side. These two faces would be parallel. Now, I want to show you one tricky thing about parallel edges on a cube. What about this edge right here and this edge right here? Are they parallel? Well, they'll never meet, will they? But we don't consider them to be parallel because they're not on the same plane. Parallel edges have to be a part of the same face to be considered parallel. These two are not on the same plane. Now, I should sort of rephrase that. They don't have to be on the same face. They just have to be going in the same direction. See, this one here, let's look at this top one again. And this one back here, this back one would be parallel because they're going in the same direction. But this top one here and this edge down here are not going in the same direction. So they're not considered parallel. So to be parallel edges, they have to be going in the same direction. All right, so hopefully you understand what intersecting lines, edges, and faces are, perpendicular lines, edges, and faces are, and parallel lines, edges, and faces. If you have any questions, please contact me directly, and thank you for watching.